Oh, breathe.
Just a reminder that the 9 weeks ends this Friday. Okay, so some of you are right on the border of a certain grade, maybe right on the border of passing. Okay, so you need to get any makeup work turned in to me by Friday. Okay, I will take it all the way up until Friday. So get any makeup work to me by Friday so that you can pass, okay, or have the grade that you want this 9 weeks. All right. So today, the final section in Chapter 2 that we're going to take a look at is actually really similar to Section 2.7. Okay, what we did 2 sections ago, where we were looking at 2 parallel lines cut by a transversal. Okay. In this section, we're just going to kind of reverse our statements. So in that section, okay, we were looking at something like this, 2 parallel lines cut by a transversal, and we said if these lines are parallel, then a whole bunch of angle relationships happen. Right? We said if the lines are parallel, then corresponding angles are congruent. And corresponding angles were angles in the same position. Okay? We said if the lines are parallel, then alternate exterior angles are congruent. Then alternate interior angles are congruent. Then consecutive interior angles are supplementary. Today, all we're going to do is reverse that statement. Okay? Instead of saying we're assuming the lines are parallel, then these things are true, we're going to say, well, if those things happen to be true, then the lines are parallel. Okay? So it's going to be really similar to what we did. Right? So up here, we have all of those statements listed, right? To determine if lines are parallel, we can say, well, if corresponding angles are congruent, then the lines are parallel. If alternate exterior angles are congruent, then the lines are parallel. If consecutive interior angles add to 180 or are supplementary, then the lines are parallel. If alternate interior angles are congruent, then the lines are parallel. So we talked about those 4 already. There is actually one new one on here. The last one says, if 2 lines are perpendicular to the same line, then those lines have to be parallel. So what we're saying is, if we've got some line perpendicular, and then we've got another line that's also perpendicular to that same line, then those 2 lines would have to be parallel. Okay? So we have 4 ways that we've already talked about, and then one new one to determine if 2 lines are parallel. So what that looks like, okay, if we look at this first example, it says we're told that the measure of angle 1 equals the measure of angle 2. So these 2 angles are equal to each other. From that, we want to figure out which lines that we can say for sure are parallel. Okay, so can I say that R and S are parallel, or can I say M and N are parallel? Which ones? Well, if all I'm given is information about angles 1 and 2, I don't know anything about angles on line N. Okay? If all I'm given is that angles 1 and 2 are equal, right? I mean, I can essentially ignore line N because I don't know anything about the angles on line N. If I know 1 and 2 are the same, I can only say that R and S are parallel, okay? Because I'm just looking at, well, 1 and 2 are on lines R and S, and those 2 angles are the same. So remember, our notation for parallel is just 2 parallel lines between them. So we can say R is parallel to S. Then it also asks to give the postulate or theorem that justifies your answer. So we want to tell why we know that R and S are parallel. So, I mean, we're looking up here. Okay, we're saying, well, if corresponding angles are the same, lines are parallel. If alternate exterior angles are the same, lines are parallel. So we just want to identify the relationship between these 2 angles. So 1 and 2 here would be, What relationship? Are they corresponding? Alternate exterior, consecutive interior, alternate interior? What's the relationship between 1 and 2 here? Corresponding. Yeah. So they're in the same position, right? Bottom left, bottom left. They're in the same position. That's corresponding. So I can say that R is parallel to S because corresponding angles are congruent. So what if I told you instead that this angle and this angle were congruent? First, which two lines could we say are parallel? We could say M and N are parallel then. Okay, if I know for sure that these two angles are the same, I could say M is parallel to N. Why? So yeah, that's the term. Yeah. These two angles are alternate exterior angles. So if I know that these two angles are congruent, I could say M is parallel to N because alternate exterior angles are congruent. Okay, so that's the first idea here. Okay, just using these relationships that we've already talked about to now prove that lines are parallel. Okay, if I know that these relationships are true, then I can claim that certain pairs of lines are parallel. Okay. Questions on that idea? The other idea for today is actually basically exactly what we did in section 2.7. The directions are just a little bit different, but the process to solve the problems are going to be the same. So if we look at this example, it says find the measure of angle ABC so that M is parallel to N. Right? Before we said, well, assume M and N are parallel, find this angle measure. Now we're just saying find the measure of the angle so that the lines are parallel. It's the exact same process. So what we want to look at, something like this, is the angles that we're given. So here I'm told this angle is 3x plus 10, and this angle is 6x minus 20. What would the relationship be between these two angles? The name would be alternate interior. Okay, they're on opposite sides of the transversal, both on the inside of the parallel lines. So then, how would I set up an equation here to solve for x? Yeah, these two angles are going to be equal to each other. So we would say 3x plus 10 equals 6x minus 20. So to solve, the x's on one side, get the numbers on the other, divide by 3, we get that x is 10. Is that my final answer? No, we got to plug it in, right? Because it says find the measure of angle ABC. So I will plug 10 in here. Measure of angle ABC will be 6 times 10 minus 20. So 60 minus 20 gets me 40 degrees for the measure of that angle. So for problems like this, okay, we're doing exactly what we did a couple of sections ago. We're figuring out whether the angles should be equal to each other, or whether they should add to 180, and then setting up an equation, solve it, and then making sure we answer the question. Right? So here we had to plug x back in to answer what the question was asking. Questions. So on the bottom there are 6 problems, okay, of this type where we need to set up and solve an equation. Right? So we have to determine whether the given angles should be equal to each other or whether they should add to 180. Okay, so we're going to take a little chunk of time here, and you guys solve these problems here. Alright, we had a few volunteers put up the answers here for 1 through 6. So I think number 1, we should get x equals 15. And these are alternate exterior angles. 2, we get x equals 10. And these are alternate interior angles. For number 3, x equals 25. And these are also alternate interior. For 4, x equals 7. And again, these are alternate interior. For 5, x equals 20. And these are alternate exterior angles. And then finally, number 6, x equals 10. And those are corresponding angles. Any questions? No, we're going to do them back tomorrow. So your homework